Hello, everyone. Thank you for being here. Today, I will be presenting our paper called Spatial Metaphors for Multidimensional Design Gallery Interfaces. My name is Naghmi, and I co authored this article with Halil, Erhan, Robert Woodbury, and Alissa Antle. It is widely known that when designers explore, they reflect on their decisions and interact with the design space to make sense out of it and eventually make an informed design decision. However, we don't see much of a system support for such exploration. In fact, most of the systems today only allow working on a single model at a time. We know that parametric tools have impacted the overall design practice with the introduction of generative mechanisms. Using these tools, designers can very quickly produce hundreds and thousands of design variations. But still, we see very few systems supporting direct interaction with these large numbers of solutions through visual galleries, though most of them allow interacting with the design data, but not so much with the gallery of design options. Hence, the challenge remains for not only how to produce this gallery, but also how to interact and manage it for sense making analysis. As part of the background, we reviewed existing research on exploratory techniques and interfaces. We identified 60 plus systems that provided some way to explore design space. We classified those systems into four categories based on their underlying representation used for exploration on y axis and their degree of automation in performing exploratory tasks on x axis. The categories are genetic exploration, history based exploration, parametric exploration, and rule based exploration. We ask this question that if the literature has so much emphasis on design space exploration using visual representations, and current parametric tools are able to generate a huge amount of design data with the potential to generate related visuals as well, then why we have yet to see design space gallery like interactions and techniques to be adopted in computational design tools? Maybe it is because we don't have the answer to an important question. We don't know what will designers do with large gallery of alternatives and how can they interact with this large gallery. We don't know what their design process will look like and what are the space use patterns when designers are presented with large gallery. And if there are any spatial metaphors that can help us transform designers' physical actions to digital implementations for future design exploratory interfaces. Through our work here at Computational Design Lab at SFU, we set out to find the level of support expert designers might need in their work environment when working with a gallery of alternatives. As part of the experimental setup, we developed a parametric model of a hypothetical residential building with gray cubes representing apartments, green represented gallery spaces, and red represents load bearing structures. The process of creation of this model is documented in our previous paper. Here's the sample of the gallery generated from the base model that we used for the experiment. For the experiment itself, we kept an open-ended design scenario to promote exploration using incomplete requirements rather than well-defined goals to avoid promoting a mere selection. After running a pilot test, we made a few adjustments, and here's what the final setting of the lab experiment looked like. We coded the audio video data collected from the experiment and represented it using a custom built visualization tool. The tool helped us to view designers' actions and tasks in relation to the physical use of their work environment. This also helped us to observe larger patterns in their process, which wouldn't have been possible to recognize otherwise. Now, I'm not going to talk much about the findings from the coded data. Most of the findings are already published in our previous publications. We did a mixed method analysis, and I'm briefly going to present primary findings in the next couple of slides, leading onwards to the list of spatial metaphors that we propose in this paper. We notice that as important as it is to observe the design process, it is equally important to observe their spatial arrangements and structures when the participants looked at a large number of design alternatives. Briefly, the most prominent observation made under the process was their cycle of design tasks. Consistent with the design literature, we observed that the participants performed the observed task in a cyclic nature. They started by gathering requirements to build criteria. They immediately tested those criteria. If worked, they move on to applying them onto the rest of the alternatives. If a criterion failed, they went back to rebuilding a new one and the cycle repeated. After every successful testing or application phase of a criterion, they reflected on their design decisions. While reflecting, sometimes they would also manage their workspace in parallel. Here's an example of this process of our participant 01. And here's the example of this cycle seen as in the process of participant number 2. The first repeatedly observed finding under spatial structures was the use of spatial zones. Participants partitioned their work surfaces into zones, more prominently into 3 zones, called active, analysis, and storage zones. The active zone was the immediate workspace with respect to the participant to perform tasks like comparing, filtering, focusing, etc. The analysis zone was a primary and opportunistic workspace where the participants recorded their selections and reflected on their design decisions. The storage space was a secondary workspace where the items were stored and left to be used in the later stages. Second primary observation under spatial structures was their scanning mechanisms. When it comes to viewing and managing thousands of design alternatives, the crucial scanning and arrangement techniques are highly coupled. Broadly, we observe 3 styles of scanning mechanisms: scanning multiples, serial viewing, comparing multiples, and each of them is published in our previous publications. To understand the data in a meaningful way, we separated the observations made on their use of space versus the observations on the design process, and we list them here one by one. We notice our participants develop dynamic zones that will change its size, location, position relative to the participant's own position and the need of the task at hand. They used editable layout strategies to organize their designs spatially to embed design decisions. They made collections and did operations on them like initiating a collection, removing, branching, or merging multiple collections. They compared alternatives and collections with each other. They viewed alternatives serially one by one versus viewing them in groups by placing them side by side versus putting them all such as to enhance their visual comparison. Sometimes they would put designs in a way to they would put designs upside down in a different orientation to embed certain design property using the physical properties such that it quickly um, is identifiable visually. They also use sticky notes, markers, tagging devices to add another layer of information on design alternatives and collections. Building on our observation, in this paper we propose spatial metaphors. The first one is the divide metaphor, that is further divided into dividing zones and divide designs. I will be defining them in my each one of them in my upcoming slides. Here are the evidences in our experimental data leading to the divide metaphor. The second metaphor we extracted from our findings is the place metaphor, which is further divided into place to arrange, place to scan, and place to compare. Here are the evidences to show the need for place metaphor. Finally, we have a mark metaphors representing visual marks, tags, notes, and ranks. You can also see the examples in our experiment where participants used visual marking operations. Altogether, in our paper, we present 3 sets of spatial metaphors. Now let's see very quickly how can they be implemented in an interface. Divide is when we introduce a physical or a logical distance between any 2 or more elements. Distance, relative location, size, shape, connection, and separation between every two designs play a vital role in making sense of a gallery space. We propose interface designers to use divide zones. Divide zones refers to having multiple interactive zones with an ability to dynamically switch between them. Divide design method refers to organizing and composing designs into collections. Place corresponds to actions to support decision making using spatial structures. It is further divided into place to arrange, place to scan, and place to compare. Mark represents actions and structures to add a layer of information on top of existing data layers. Mark acts as an aiding device to code and highlight a substance of interest or of specific property. Mark is then divided into bookmarks, tags, notes, ranks, and rates. After we had a list of these metaphors, we then looked back into our collection of systems. We revisited our collection and we picked out five systems based on their ability to provide an access to design forms and design data within a single integrated interface. We compared these systems to see how well they integrate the spatial metaphors we propose as a result of our experiment. It turned out that although most of these systems do have an initial demarcation of the spatial zones within their interfaces, almost all of them, with an exception of D star, provides either rigid or semi-dynamic zones. Similarly, none of them provide support to make collections a very basic operation for clustering or grouping objects for an interface with a large number of design options. Almost all of these systems had some way to organize and compare alternatives, which is great. We do envision future interfaces with large number of alternatives to keep implementing these place operations. But when we looked at the spatial mark metaphor, to our surprise, we noticed that none of the systems had any way to visually mark or bookmark an alternative. Of course, with an exception of D star, once again, none of them provided any means to tag designs or place small comments or notes for further referencing. Almost all of them had interface support to rank design alternatives, which again is a great tool. In the end, the one takeaway from this presentation would be that even though parametric systems allow generating a huge design data and look at design alternatives, in order to make sense of this data and the design space, we need interfaces that are equipped with spatial interaction and organization tools. Our paper presents a list of some of these tools in form of spatial metaphors based on the results of an experiment we conducted. This paper is just a beginning. In future, we must look at, once implemented, how well these metaphors help ease the process of design exploration. Thank you.